This is 2023, the trial exam paper from Kedah, paper 2. Let's look at the question number 3. The diagram shows a dual time watch, which are Kuala Lumpur time and the London time in circular shape. So given that the time in Kuala Lumpur is 11 a.m. and the time in London is 3 a.m., the radius of the circle of Kuala Lumpur time and the radius of the circle of the London time are 15 mm and 8 mm respectively. Now we use capital R to represent the KL time circle. So that's 15 mm because it's bigger, the radius is bigger. The one smaller one, we use small r to indicate that is the London time. So 8 mm. So we need to find the difference between the circumference of the circle of the KL time. That means for the KL time, the circumference is 2 pi r, okay, which is 2 pi times with the r 15 mm, because it say in terms of pi, so we just leave the pi alone. So 30 pi mm. Okay, that is the circumference of the circle, and we need to find the difference between this and the major arc of the London time. Now, the major arc of the London, I think this part is a little bit confusing. It should be the revealing major arc of the London time circle. Otherwise, some people, they will interpret it as the London time is 3 o'clock, so the major arc should be this one. So some people may interpret that way. So that if we add this, the revealing major arc, lengkup major terdedah, okay, terdedah bagi waktu London. So that should be the way. So the London time S equals to R theta, small r and the theta. Now the small r is 8. Now what about the theta? The theta is, now you look at the London time is actually being divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of another 2, 12. So 10 out of 12. So we can just calculate that. Theta uh, equals to 10 out of 12 of 2 pi. Okay, and when we simplify it, we will get 5 over 3 pi. So let's put this one in here, 5 over 3 pi. Therefore, we have 40 over 3 pi. So now let's put it together. The difference will be taking the KL time circle minus the London time circle, the arc. So when we minus this, we have find the lowest common multiple, 3. So 90 minus 40, we have 50 over 3 pi mm. Okay, that's it for the first part, part A. Now next, the second part. The B shows the display of the watch of London time. Okay, the designer of this watch wishes to decorate the shaded region using round-shaped diamonds with radius 0.76 mm. Okay, find the maximum number of diamond used. Okay, we need to know how many, diamond, the diamond which is in the shape of circle, how many we can fit in. So how do we do this? Let me just enlarge this diagram. So I have every circle, okay, it will make, we know that the circle from the center, the line here is the tangent to the circle. So it make 90 degrees here. So if I add another tangent, which that means I draw another line from the center of the circle, I will have created another tangent that make 90 degrees here. Okay. And we just need to find out what is the angle that each diamond can subtend. And therefore, out of the 360 degree, okay, we can find out the number of diamond that can fit into this shaded region. So since it fits nicely at the shaded region, which means, okay, we know that from here to here, Let's find out use the right angle triangle to help us to find. Let me just blow up this right angle triangle. So it should be like this. This is 90 degrees. This is the center of the London circle, whereby the radius here, 0.76, and the length here, basically, if we reach up to the end here, it should be 8. Okay, if we reach up to the end here, it should be 8 mm. But I just need to take away this part to produce the length of the hypotenuse, which is 8 minus 0.76. That gives us 8 minus 0.76, 7.24. So we have 7.24 mm. And from there, we can find this angle here. Let's call this theta. Therefore, theta, if we sine, because to this angle, we have the opposite length, and the hypotenuse is the side that is always opposite the 90 degrees. So we shall use sine function, because according to Sohcahtua, opposite and h involves sine. Sine theta is the ratio of opposite divided by hypotenuse. And when we find the arc sine using the calculator, we will get 6.03 degree. Now that is theta, but for every single diamond, it will subtend 2 theta. So 2 times 6.03, we have 12.06 degree. So we know each diamond need 12.06. So out of the 360 degree, by the way, it's not 360 degree. We only take up 10 out of, we only take up 10 out of 12 parts. So the angle will be 300 degree. So we shall use 300 degree, divide it by 12.06 degree. We got 24.88. The number that we get is 24.88. Therefore, the maximum diamond to be used, okay, now 24.88 is here, so it will not be more than 24.88. So the maximum integer will be 24. So that's it. We found the number of maximum diamond used, 24.